Good morning, distinguished guests and colleagues. It is a profound honor to address you here at ICONS, the International Conference on Computational Science and Engineering for Society, specifically for this inaugural International Conference on Leadership in AI, ITSM 2026. My name is Gabriel Silva-Atencio. Today, I am privileged to share my research titled An Integrated Governance Framework for Ethical, Risk-Aware, and Compliant AI in IT Service Management. As we integrate artificial intelligence deeper into our social and technical infrastructures, we face an unprecedented challenge: how to govern systems that are, by nature, probabilistic and adaptive. My work focuses on bridging the gap between high-level ethical theories and the concrete day-to-day operations of IT service delivery. Over the next 10 minutes, we will explore why traditional models are failing and how this proposed integrated framework provides a roadmap for responsible, trustworthy AI leadership. Let us begin by examining the core problem, which I define as the AI governance paradox in IT service management. Currently, AI is no longer a peripheral experiment. It is increasingly embedded in core processes like incident management, problem prediction, and intelligent automation. However, this creates a paradox. While AI brings undeniable operational benefits such as increased speed and predictive capabilities, it simultaneously introduces a new spectrum of ethical, operational, and legal risks. The fundamental issue is that current governance models are fragmented. They treat ethics, risk, and compliance, which I refer to as ERC, as separate, siloed activities. This fragmentation is inherently insufficient for the dynamic and adaptive nature of AI systems. Principles like fairness and transparency remain dangerously abstract, while critical operational risks like model drift often go completely undetected until significant damage has occurred. We need a more cohesive approach. To understand the depth of this issue, we must look at the current state of literature, which currently consists of three siloed conversations. First, AI ethics literature offers a strong consensus on high-level principles like fairness and accountability, yet it suffers from a major gap. These principles remain abstract with almost no guidance on how to operationalize them in a technical environment. Second, traditional IT governance frameworks like ITIL and COBIT were designed for stable, deterministic processes. They are fundamentally ill-equipped to handle probabilistic AI failures such as adversarial attacks or the gradual degradation of model performance. Finally, the compliance literature remains largely focused on reactive, retrospective audits. This approach is no longer viable in the face of proactive regulations like the EU AI Act, which requires safety checks throughout the entire system lifecycle. Consequently, there is an urgent need for a unified, lifecycle-oriented framework that integrates ethics, risk, and compliance from the moment of design to the point of disposal. This brings us to our primary research question. How can a unified governance framework be designed that successfully integrates ethics, risk, and compliance for the responsible use of AI in IT service management? To answer this, I propose the Integrated ERC Governance Framework. This framework is not just a set of guidelines, but a three-layer lifecycle-oriented artifact designed to embed ERC directly into core ITSM processes. Our goal was to move beyond the high-level what of ethics and focus on the how, transforming abstract principles into verifiable, auditable actions that practitioners can perform. The development of this framework followed the design science research methodology, ensuring that the resulting artifact is both theoretically sound and practically relevant for the complex organizational problems faced by modern IT departments. Regarding our methodology, we utilize design science research as it is ideal for creating innovative IT artifacts that solve real-world organizational problems. Our design process was informed by three vital information sources. First, we analyzed legal texts, including the forthcoming requirements of the EU AI Act and the ISO 42001 standards. Second, we synthesized the current AI ethics and governance literature. Third, we ensured alignment with established ITSM standards like IDIL and COBIT to ensure the framework remains compatible with existing enterprise practices. The evaluation of this framework was multi-staged and rigorous. We engaged three distinct expert panels, comprising ITSM practitioners, AI ethics researchers, and legal experts, using a Delphi-based method. We then tested the framework through an illustrative use case focused on an AI-powered critical incident management system, followed by a thematic analysis of the qualitative feedback received. The result is the three-layer ERC governance framework. Let me walk you through its architecture. Layer 1 is the foundation, which represents the AI-enabled ITSM processes, the operational base where the acquisition, design, and disposal of AI systems actually happen. Layer 2 is the control layer, which hosts the three interlocking functions of ethics, risk, and compliance. The ethics function translates principles into practice, the risk function manages AI-specific threats, and the compliance function ensures strict regulatory adherence throughout the lifecycle. Finally, Layer 3 is the enactment layer. This is where governance becomes real through concrete artifacts such as forms, standards, logs, and dashboards. The crown jewel of this layer is the ethical impact assessment process, which ensures that every decision made regarding an AI system is documented and accountable. Together, these layers create a closed-loop system for responsible AI management. Our first key innovation is the Ethical Impact Assessment, or EIA. The problem we aim to solve here is that ethical principles often lack accountability and are purely aspirational. The EIA solves this by creating a staged process integrated directly into the AI lifecycle. At every major stage, whether it is design, procurement, or deployment, practitioners are required to follow 3 steps. First, they must identify potential harms, such as bias against specific user groups. Second, they must document specific mitigation measures, such as the use of fairness-aware training or diverse datasets. Finally, they must sign an ethical compliance certificate. This transforms an abstract conversation about ethics into a verifiable, auditable artifact. By doing this, we turn ethics from a vague aspiration into a closed-loop governance activity, where every risk is accounted for and every mitigation is signed off on by a responsible party. The second innovation is dynamic AI-specific risk management. Standard IT risk frameworks often miss the unique ways in which AI can fail. To address this, we have integrated an AI-specific risk library into the framework. We categorize these risks into 3 main signals. First is model degradation and drift, which we monitor via data drift detection algorithms. Second is adversarial manipulation, where we utilize input anomaly detection to prevent malicious actors from fooling the model. Third is feedback loop failures, monitored through rigorous outcome analysis. The significant impact here is a shift in posture. We move risk management away from periodic, once-a-year reviews and toward a model of continuous monitoring and mitigation. This ensures that the governance framework is just as dynamic and adaptive as the AI systems it is designed to oversee, catching errors before they escalate into service outages. Our third innovation is the compliance engine. Regulations like the EU AI Act now demand proactive, continuous compliance rather than just retrospective audits after the fact. Our solution is a compliance engine that creates a live mapping matrix between specific regulations and technical controls. For example, Article 10 of the EU AI Act focuses on data governance, requiring that data provenance and quality be ensured. Within our framework, the EIA checks data lineage while the risk module monitors data quality signals in real time. The framework then automatically collects these compliance artifacts as evidence. This effectively shifts compliance from being a reactive, administrative chore that slows down development into a built-in design feature of the IT service itself. It ensures that by the time an auditor arrives, the evidence for compliance has already been generated and verified through the daily operations of the system. The evaluation results were highly encouraging. Thematic analysis from our expert panels provided vital insights. ITSM practitioners confirmed the utility of the framework, though they initially worried about governance overhead, which led us to implement a tiered review design to keep processes lean. AI ethics researchers validated the conceptual soundness, calling it the missing middle layer that had been absent between theory and implementation. Legal experts confirmed its alignment with both the EU AI Act and ISO 42001, stressing that the artifact trails are essential for regulatory defense. Quantitatively, in our case study of an AI-powered incident management system, we found that using our AI-specific risk library increased the initial risk score by 40% compared to a standard IT risk framework. This increase is a success, as it means the framework identified critical risks, like adversarial attacks, that were previously invisible to traditional methods. In terms of discussion and implications, the main contribution of this research is that it provides the first operational bridge between high-level AI ethics principles and day-to-day ITSM practices. We have successfully addressed the implementation gap by converting principles into verifiable artifacts like EIA certificates and compliance logs. Furthermore, we are enhancing IT governance theory by extending static frameworks like COBIT and ITIL to handle the unique challenges of probabilistic systems. We are redefining compliance as a compliance by design posture that is ready for the upcoming regulatory landscape. However, adoption requires several critical enablers: an executive mandate from leadership, the formation of cross-functional teams involving data scientists and legal experts, and the technical integration of these governance tools directly into existing MLOps platforms to ensure a seamless workflow for technical teams. In conclusion, this study presents the first rigorously designed and evaluated integrated governance framework for AI in IT service management. Our innovations, the 3-layer architecture, the ethical impact assessment, the dynamic risk library, and the compliance engine, provide a blueprint for responsible AI leadership. The key insight I want to leave you with is this: AI governance is not a barrier to innovation. When designed correctly, it becomes a powerful enabler of trustworthy, resilient services that can scale safely. Looking forward, we plan to conduct longitudinal case studies in production environments and develop further technical tools to integrate these controls into MLOps platforms. We are also looking at maturity models to help smaller organizations adopt these practices in phases. Thank you for your time and attention today, and I look forward to your questions.